in the Tuesday one. Yep. So on Tuesday, we wrapped up doing 17, 18, and 19. So real fast, we're going to recap these 3 questions, then we're going to go to the next 3. So for 17, 18, and 19, first we had to determine whether or not it was a function. So why is 17 not a function? Because there's a repeated input. There are 2 negative ones in the x's, right? And so then we did domain. Domain is our x values. So we just took our x values and wrote those. Then our range is our y values. Okay. Then for 18, why is 18 not a function? Because 6 goes to 2 y's. Okay. Now, we took our x values for our domain and our y values for our range. 19, why is 19 a function? Passes the vertical line test. No duplicate inputs. Okay. Then we took our x values and our y values. So now we're going to go ahead and we're going to look at 20, 21, and 22. So these are different than the graph of 19 because 19 just has 5 points on that graph. Whereas number 20 is a continuous line for the graph. So we still determine whether or not it's a function the exact same way, but what changes is how we do domain and range. So is 20 a function?
Yes.
Yes, it is a function. It passes the vertical line test, so it is a function. So when we do the domain and range of a function that is a continuous line like this one is, okay, we have to make sure we include every part of that line. So if I was to just do the places where there's points, like on the grids, am I including that entire line by just doing those points? No, okay, because there's points in between all of those. Okay, there's infinitely many points on that line. So what we do is we do an interval where it starts to where it stops, okay? So when we are doing the interval notation for domain, okay, remember domain is your x values, and we're going to go from left to right, okay? So we're going to find the leftmost point of that graph. If I look at the graph of 20, what is the leftmost point? What x value has the leftmost point? -1, right there. Okay, so we're going to start our interval at -1. Will that get a parentheses or bracket? It's a closed dot. It will be a bracket. Okay, then we're going to go to the rightmost point. Where is the rightmost part of that graph? It is at 5. Okay, but at 5, it's an open circle. That means a parentheses. So what that tells me is that graph is everywhere between -1 and 5. That's what that interval tells me. So that lets us include every single spot between those 2 places. That's how we do domain when we have a graph. Now we're going to do range. So range is our y values. Okay, our y values, when we do this, we go bottom to top. The lowest to the highest, smallest to biggest, okay? So where is the lowest that graph gets? Where is the bottom of that graph? -3, right here, okay? So at -3, does it have an open circle? No. Okay, at y equals -3, there's not an open circle. If there is not an open circle, you assume it is a closed circle. So that means it will get a bracket. Now, where is the tallest place that graph gets? Where's the biggest? 3. That is an open circle, so it gets a parentheses. And that is how we do our domain and range with a continuous graph.
I see.
Now we're going to look at 21. So for 21, first, is that a function? No, it is not. Why is it not a function? Yep, it fails the vertical line test because it intersects twice. So we're still going to do domain and range though. So domain, again, are x's. We're going to go from left to right. So when I look at the left of this graph, what do I have on the left side of this graph? Is those points or the arrows? Arrows. When we did graphing inequalities, when I had one that looked like this, where did that tell me it went? No, when I was graphing them. Where did that go when we graphed our inequalities? It went to the left, negative infinity. So where do you think these arrows are going? Negative infinity. And infinity always gets parentheses. Now, where is the rightmost part of this graph? 4. Will it get a parentheses or a bracket? It will get a bracket. If it is not open, it is closed. Now, we're going to look at range. So range is our y's. We're going to go from bottom to top. So at the bottom of this graph, that is going left, but it is also going down. Okay, so does that graph ever stop going down? No, if I was to keep drawing it, it would just keep going on and on forever. So if it's going down forever, what do you think that's going to? Negative infinity. Then if we look at the top of this graph, it has an arrow. If I keep drawing that, it's going to keep going up forever. Where is up forever going to go? Positive infinity. So our range is from negative infinity to positive infinity. It is like infinite. Why are you laughing?
Yes.
You're being ridiculous. All right, for 22, what is our is 22 a function?
Yeah. Yes.
It is a function. It passes the vertical line test. Okay, so we're going to start with domain. We're going to go from left to right with our x values. So on the left, does that ever stop going left? So it goes to negative infinity. Does this graph ever stop going right? So that means it's going to infinity. So domain is from negative infinity to positive infinity. Now, range. Range is our y values. We're going bottom to top. So does this graph ever stop going down? So that means, does this graph ever stop going up? So it goes to positive infinity. So that is our domain and our range.
Where did he come from?
He was sitting in the floor.
I understand.
It's like infinity.
All right. Now, we are going to look at identifying whether or not it's a function from a statement. So, first for 23. Says, X is the number of hours a person has spent writing a paper. So that is our input. Then we have Y is the number of words written on the page. That is our output. Would that be a function? Why not? If you've been working on your essay for 5 hours, right? And the little word count at the bottom of your page says 3,000 words. But that's not talking about other people. It's only talking about one person. So can one person, after 5 hours, have written a bunch of different totals of essays in this context? Like, can there one essay they have been writing? Can it have 3,000 words and have 30,000 words? No, it's just one total, right? It says the number, okay? So would that be a function? Yeah. Because for every hour, they're going to have a unique output of how many words they've written. Yes, that is a function. Okay, and the reason for that, at any point, or at any hour, there is only one word count. It is unique to however long they've been writing, how many words they have on their paper. All right, now, we're going to look at 24. So Jill records the temperature at 2 p.m. for every day in June. Okay, so we're talking about the temperature at 2 p.m. and we're talking about every day in June. So what would the input be here? The day. The day in June is our input. All right. So that means our output is specifically at
2 p.m.
all right. Given Jill's data, is knowing the date in June enough to determine the temperature? If I asked Jill, hey, can you tell me the date at June 13th? Could she tell me the date at June 13th? Yeah, right. She's recording every single day. If I asked Jill at the 21st of June, what was the temperature? Could she tell me? Yeah. Okay. So that is enough to tell me that. Because each day has a temperature. That is me abbreviating because, by the way, if I do BC. It has one temp at 2 p.m. Is that relation a function? Yes, because at 2 p.m., how many temperatures are there? One. Okay, it is a function. And we know that because the date determines the date. Each date has a unique temperature. Okay, so we have looked at the domain and range of a function, determining whether or not it is a function, and looking at graphs, ordered pairs, and to mappings, all the things to determine whether it's a function. So today we are going to do 10 Delta Math questions.
9.5.
10 Delta Math questions. Go ahead and get those out for me.
That's what I was saying. What about 9.8?
Y'all are being ridiculous.
Wait, we didn't round up. Just do 9.8.
Y'all are being absolutely ridiculous. All right. So I'm going to go over how to do these. Okay. We're going to look at each section first. So for this first section we have, it says find the range of the function defined by the points below. Range is X or Y's. Y's. So I'm going to look at those points and I'm going to write the Y values. What are the Y values I have? Y values. 10, -2, -7. There we go. That's how we do that. So let's see if it'll give us another type of problem. I want one that will give us a different kind of question. We're just going to, I know, I'm purposely getting this wrong, so it'll give me a new question. Now it's a table. Okay, it says find the domain of this function by the table. Domain is our X. So when I do this, I'm just reading off the table. What are the X values on the table? -9, 7, -4, +9, -8, -7, 1. Here we go.
That seems easy.
It's very easy. Okay, now, this second section is looking at it visually from a graph. Okay, this is where we're going to have to do interval notation. So for the first one, it says determine the range. Look at this graph for me. What is it says range, so we're looking at y's. So we go bottom to top. What is the bottom of this graph? What? 0, because it goes our y value. So it's going to go from 0 with an open circle, which means parentheses. So we're going to do parentheses 0, comma. All right. What is the tallest this graph ever gets? 6, which also has an open circle, so that means parentheses. So 0 to 6. And that is what we do. Okay? Maybe the next one will give us a domain one. It will. So domain goes left to right. What is the leftmost point of this graph? -2. What is the rightmost point? 11. And they both have open circles. So we're going to do parentheses, -2 to 11. And that is all we are doing for this Delta Math. Okay? So I want you to finish that. And then for our virtual day, if you have not completed yesterday's 3.1 functions Delta Math or today's 3.1 domain and range Delta Math, that is your virtual day assignment. You have plenty of time to finish it in class. Do your best. That's what we're doing.